Okay, with number 14 we're looking to find the second derivative of the function, and the second derivative is just the derivative of the first derivative, and so the first one is fairly straightforward. F prime of x is equal to 6x plus 15. And the second derivative then is just 6. Now if we were to keep going and find the third derivative, then that would be 0, and the fourth derivative 0, 0, 0. You could take an infinite number of derivatives from the third one on, they would all equal 0. Alright, for number 15 we're trying to find the second derivative of 2x sine x, so we have to find the first derivative first. And the basic structure of this is a product rule. We have two functions, 2x and sine x. And so 2x is going to be our first function, sine x will be our second function. Alright, so we'll find the derivative of 1 d2 and then 2 d1. 1 is just 2x. The derivative of the second function, sine x, is cosine of x. Then plus 2, which is sine x, times d1, which is just going to be 2, and so that's 2 sine x. And that's the first derivative. The second derivative then, f prime prime of x, again we have two terms, and the first term is also a product of two functions, and so we're going to have to use the product rule on that, just as we did with the original function 2x sine x. Now we're going to have to find the derivative of 2x cosine x. So that's 1 d2. The derivative of cosine is negative sine x. That's 1 d2 plus 2, which is cosine x, times the derivative of 2x, which is 2. So we're going to have plus 2 cosine x. And then we need the derivative of the last term, which is 2 sine x. And the derivative of 2 sine x is going to be 2 cosine of x. So just make sure you understand the first two terms in that derivative come from 2x cosine x. It's the derivative of 2x cosine x. The last term, 2 cosine of x, comes from the derivative of 2 sine x, the second term in the first derivative. Alright, we can do a little simplification on that. For example, the 2 cosine x plus 2 cosine x is equal to 4 cosine x. And since that's positive, I'll put that first. And then minus 2x sine x. And that would be our second derivative. We could factor out a 2 from that, but that's not that important here. Okay, so I'm going to go on to number 16 then. And with number 16, we're looking to evaluate the second derivative when x is equal to 2. So the first derivative is going to take a little time, but the second derivative we don't have to simplify it. So we'll go through the steps here. We do have a basic quotient rule here for the first derivative. And so that's low d high. The derivative of the numerator is 2 times 5, which is 10x plus 2. So that's low d high minus high d low, and since the derivative of the denominator is just 1, that's going to stay the same. But do remember to put that in parentheses because you're subtracting that entire term, that entire expression, so you need to apply the negative sign. And that's all over x plus 1 squared. Now we are going to need to multiply out and simplify the numerator. And of the first two factors, those two binomials multiplied out should give me 10x squared plus 12x plus 2 minus 5x squared minus 2x, and all over x plus 1 squared. So that should give me simplified 5x squared plus 10x plus 2 divided by x plus 1 squared, and we need the derivative of that. And again, that's low d high. This time the denominator is x plus 1 squared, and the numerator is the derivative of is 10x plus 10. So that's low d high minus high d low. Now the denominator is x plus 1 quantity squared, and so its derivative by the chain rule